Hey guys, welcome to the Level 1 MCAT paper from 2021. This is day one paper. For those of you that are joining me for the first time here, welcome. I guess I'm going to kind of help you guys out for the next 3 years, hopefully. Anyway, how this video is going to work out is I actually go through each question one by one, tell you guys what you guys need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question. And then have a go by yourself with the question just to see how far you get, and then unpause the video to check my answers. Yeah, so without further ado, let's get started. That's right. How can I forget this? I know a few people have been asking me in the past how they can actually support me or this channel. One thing I did do earlier this year is start my own store. You can find it on Instagram as well as on Facebook, Infinity Plus One Store. Just making a few things, making signs, cake toppers, and things like that, whatnot. So if you need anything like this or know anyone that needs anything like this, yeah, just shout my name out to them and just drop us a follow on Instagram. Much appreciated. So without further ado, let's get started. All right, guys, so we are off with question one here. What do we got here? It's always nice to start with a nice question, and I guess this year they kind of kept the same theme going here. So what we've got here is just finding the value of 2x squared minus 3xy. One thing that I always recommend you guys to do is put a bracket around whenever you're dealing with squares or cubes or anything like that. So in this case, we know that x is -3, so I'm going to put that as -3 squared minus 3 times x, which is -3, multiplied by y, which happens to be 4. Okay, I've got 2 times -3 squared is +9, and I've got -3 times -3, which is equal to +9, and I've still got to multiply by 4. So I've got 2 times 9, which is 18, plus 9 times 4, which is 36, and this is equal to 54. So when you look at the marking schedule, I don't know why they use U and what do you call it? U and R? No, U and A. So let me just show you what I mean by. Can I grab this? Yes, I can. There we go. So as you guys can see, your answer is actually worth 54, but they actually give this as a U grade. Now, I'm going to be honest with you guys. I still don't kind of fully understand why they decide to go U and then A and do all sort of weird things. But like the way I do it is like right now this is considered an achieved question, which is what that U means. So we can actually call this achieved, right? And notice also it says that numerical errors are not allowed. So they want a full answer for this. So in saying that this question is worth, I'm going to put that as achieved. And then we move on to the next question. So question number letter B, what we have is we've got equation has two solutions, P and Q, with P being greater than Q. What's the value of P minus Q? So interestingly enough, what we've got here is a quadratic equation that we need to solve. All right. So I guess the first step you want to do is even if you can kind of just write the equation down. So you've got 6 is equal to 2x squared minus 11x. And I guess the first thing you want to be noticing is that you've actually got an x squared here and you've got an x here. And whenever you see something like that, automatically you should recognize that this is a quadratic, which means one of the sides has to equal 0. So I'm going to keep the left-hand side equals to 0, which means I'm going to get 2x squared minus 11x. And because the 6 is coming to the right-hand side, it's changed symbols. This is going to be minus 6. So this is my initial quadratic equation. Now, the question actually says that there are two solutions. Now, two solutions means we've got two answers. Now, we know that a quadratic has actually got two answers. Now, looking at the, oh wow, looking at the answer sheet, looking at the schedule, it doesn't say anything about using quadratic formula. So if you know quadratic formula and you can actually work this out, I generally don't think there's a problem with that because it does say at the bottom of the schedule accept alternative formats of the answer. So you could, well, that's a fraction really. So yeah, I think think you should be all right, but like I'm going to show you guys the factorizing way anyway. So with the factorizing way, I mean, there's an algorithm for this, and I've got a couple of videos, so go check it out. So the first thing I do is 2 times -6, which is equal to -12. And I'm basically looking for two numbers that multiply to -12, and they also add up to -11. So my two numbers are going to be, let's see, -12 multiplied by 1, and -12 plus 1 is equal to -11. So basically what I'm going to be doing is I am going to be replacing this -11x with -12 and +1. So if you think about the quadratic, it's going to be rewritten as 0, 2x squared minus 12x plus 1x minus 6. So all I've done here is I've replaced the minus 11x, which is in that pink highlighted area, to -12x plus 1x. And the reason I do this is because I want to be able to factorize the first two elements and then the second two elements. So what do I mean by that? I've got 0, which I don't know why it's becoming a circle. I got 2x as a common factor, so I can take it out. And I've got x minus 6. And as for the right-hand side, I've got 1 as a common factor, so I'm going to put that as +1. And I'm going to take it as x minus 6. And of course, if you guys have been doing this, then you know that x minus 6 is a common factor, and the other common factor is 2x plus 1. Now, just to reiterate, where did I get that 2x plus 1? Let me just grab a different, where did it go? Hang on a minute, let me go find that. All right, so what we have is we've actually got the 2x from there to there, and the +1 just ends up with there. So those are our two factors at the moment, right? Now with our two factors, we then have got to, what do we got to do next? We've got to actually find out what our two solutions are. So we're actually going to go x minus 6 is equal to 0, or 2x plus 1 is equal to 0. So our first case, we're going to get x minus 6 equals 0. We know that x equals to 6. And in our second case, we're taking the 1 across, which means it's going to become -1. And of course, x is equal to -1 divided by 2. And so those are our two solutions right now. Our two solutions are 6 and -12. But if you look at the question itself, the question is asking us for what is the value of p minus q. Now, p and q are just the two solutions. So we can really say that 6 is going to be p, because it actually says p being greater than q. Because of that, we can say that p is equal to 6 and q is equal to -12, which means if we do p minus q, we're going to get 6 minus -12, which is the same as 6 plus a half. So you can write that as 6.5 as your final answer. Okay, so grades wise, correct difference between p and q find is going to give you an excellence grade. A merit grade is if you find both of these values, you get a merit. But let's say you get the wrong values for this, and then you do like the correct consistent difference, you also get a merit for that as well. Now, achieved is factorizing the quadratic expression. So this is achieved right here. Or consistent solving of the quadratic equation. So if you make like a mistake with the quadratic equation, but then you get the right solutions, you could get an achieved as well for that. Cool. So let's go to the next question. Cool. So with the next question, what we have is 2x plus m squared. What is it? Find the values of m and n so it'll make this equation true, given that both m and n are positive numbers. Okay, so all we got to do is we've actually got to expand the left-hand side and then just equal it to the right-hand side and then kind of try and figure it out. So let's see. We're going to take the 2x plus m first, and we are going to expand it. So that means we're going to get 2x plus m squared is actually equal to 2x plus m times 2x plus m. So when we do this, we do our whole FOIL, whichever one you want to call it. So the insides, outsides, whatever, right? So we're going to do, we got 2x times 2x, which is 4x squared. 2x times m, which is 2xm. Then we've got the bottom part, which is m times 2x and m times m squared, which means m times m squared, m times m. So we got another 2xm, and we've got plus m squared. So we're going to simplify this. We're going to get 4x squared plus 4xm plus m squared. Now this is what the right-hand side is equal to. So what do I mean by the right-hand side? This part right here is equal to 4x squared plus m squared. But what we also know is that this right-hand side is equal to the green. Like, we're trying to figure out what the values of m and n are so that both the yellow and the green is going to be the same. So we're going to write the second equation, the green equation, right next to it, right? So we got 4x squared plus nx plus 9. And now this is the green part of the equation. So from here, it's a case of matching things out. So what do I mean by that? Now, let me put it this way. If we want this equation to be equal to each other, we have to match all the parts, like the coefficients or the number by itself, the x's, we have to match the x squared. So let's have a look at the x squared first. Now, we've got 4x squared here, and we've got 4x squared. All right, so those two are equal, so we don't have to worry about it anymore. The next thing we're going to be looking at is, I need a different color. Let's go with this one here. We've got 4xm nx. All right, that means the 4mx should equal to nx. Okay, let's just bear with me on that one. And then the final one is we've got m squared, which does not have any x next to it. And we've got this 9 by itself, which doesn't have any x at all to it, attached to it. That means m squared is equal to 9. 4xm is equal to nx. So let's actually take the m squared first. So if we actually write down m squared is equal to 9, we are going to get m is equal to plus or minus 3. But if we go back to the question actually says m and n are positive numbers. And because of that, we can actually say, therefore, m is equal to positive 3. Then we got to look at the n value. So we're going to take that light blue one, which is 4xm equals to nx. Now we know what m is equal to. M is equal to 3. So we're going to replace the 3, and we're going to get nx. So what are we getting here? We've got 12x equals nx. And because both of the x's will cancel out each other, we can actually say n is equal to 12. All right, what do I mean by that? Let me just go one more step here. So 12x is equal to nx. So 12 is equal to nx divided by x. And now what happens is my two x's cancel out, and I've got n is equal to 12. So I've got my two answers here, which is n equals to 12 and m equals to 3. So to get a merit for this question, you need both n and you need m. Correct expansion of 2x plus m squared could be achieved. So that's achieved is right there. And it does say it does not need to be simplified. And if you find one of the values of m or n, you could also get an achieved for that. So it's another way you could answer this question. All right, so let's go to question D. So with question D, I'm not going to lie, guys. I was a little bit kind of not annoyed. It's just like I've seen this question come in. What do I say? I've seen this question come in level 2 algebra, so it's, I was a bit surprised to see it here at level 1. But it has always been the story with MCAT. They always like to throw a few curveballs here and there. So I'm going to show you guys how to do this a slightly different way, because the numbers are not too bad, all right? Like when you think about it with x squared. So what I'm going to do is I'm going to show you guys a slightly different method, and it might make sense, and hopefully then you can kind of see where it comes from. So when you see a question like this with something raised to the power of 4 and something raised to the power of 2, now you've always solved quadratic equations, right? And you've not actually gone into like solving cubics or anything beyond that. So one thing to notice here is if you ever see something like this, just choose a different letter. All right. Now they've actually put W4 and W squared. What I'm saying is, instead of w squared, like let's say we take x, we put x is equal to w squared. Then we can say that x squared is going to be w squared squared, which just equals to w to the power of 4. Now, what we're really doing here is called just substituting out, and then we're going to solve it later on. So let's have a look what do I mean by that. So instead of writing w4, so notice how w4 is here. Instead of that, I'm going to replace it with x squared. And instead of writing w squared, I'm going to replace it with x. So in that case, I'm going to get x squared minus 18x plus 81 equals to 0. Now, when you look at this, you're like, actually, this is one of the more easier quadratics to solve, because this is just x minus 9 and x minus 9 is equal to 0. So far, so good. We also know that we can actually get a solution for this because x minus 9 is equal to 0, which means we can say that x is equal to positive 9, because when 9 goes to the other side, it's going to be negative 9 goes to the other side, it becomes positive 9. 0 plus 9 is just 9. Now, we've not solved the equation, because when the question actually says solve the equation, you need to find solutions for w. But what we've figured out the solution for right now is x. X is equal to 9. So we kind of need to do this one more step, which is because x equals to 9, and we also know that x equals to w squared, we can rewrite this as w squared equals to 9. Because remember, that's what we did right at the beginning. We said x is equal to w squared, and because x equals to 9, we can say w squared equals to 9. But when they're asking for solutions, they want solutions in terms of just w. So we can write this as w is equal to square root of 9. But of course, square root of 9 could be written, in this case, we do need to write down both plus or minus 3. Because if we forget the minus, then that's incorrect answer, because that's only giving us one correct solution. And that basically drops it from like a excellence to a merit, which kind of sucks. But if you put down w is equal to plus or minus 3, you're looking at a grade of excellence. But if you put only plus 3 will actually get you only a merit. Correct factorization of the equation into quadratic factors. Yeah, let's have a look at the answer schedule so you guys can have a look at what I'm seeing here. So as you guys can see here, I mean, like what they've done is like they've kind of went w squared minus w squared minus 9 and w squared minus 9. I mean, there's nothing wrong in doing this. You're still going to end up with pretty much the same answer. I guess I'm looking at for achieved, even if you recognize that w4 is w squared squared, you can do it another one and you can get an achieved. Consistent solving of the quadratic equation. So if you make a mistake, but you still get an answer, you can still get an achieved for it and so on. So it's kind of hard to put down exactly where you get a merit or where you get an achieved. But I guess in this one, I would say if you had done something like this, and so you did the top thing and you kind of came here, consistent solving, right? So you got to solve it. So I'm guessing you probably would need to go somewhere here to get that achieved. Anyway, let's go to the next question, guys. I've got a lovely rearranging question here. Okay, so with this question, what we're doing is we are rearranging x in terms of y and r. Okay, so we got to make x the subject here, right? So looking at the x's, we've got an x in the numerator and we've got an x in the denominator. So what we want to do is we want to first bring all the x's to the numerator. So we're going to cross multiply in this case. So this will become r multiplied by y minus 2x is equal to 5y minus 4x. All right, so that's basically step one there. Step two is we want to actually expand the brackets. So we're talking about this brackets here. So we got to multiply those two things. We're going to get r times y, which is ry, and then we got minus 2rx equals 5y minus 4x. Now, obviously, I want to be able to bring all the x's together. I'm going to move the negative 4x to the left-hand side, so it becomes a positive 4x. And I've still got the minus 2rx here, plus ry equals 5y. Now, I know I could have taken that ry straight away. I'm just taking it a bit slow here, guys. So I've got 4x minus 2rx equals 5y. Now I'm going to bring that ry to the right-hand side. It's going to become minus ry. So far, so good. Next, what we can do is we want x by itself. And because we want x by itself, we can actually take it out as a common factor. So x is a common factor, which means I'm going to get 4 minus 2r equals 5y minus ry. And of course, now if I want to have x by itself, I need to get rid of the 4 minus 2r, which will actually go in the denominator of the whole thing. And we've got 4 minus 2r in the denominator. And guess what, ladies and gentlemen? We've just proven x in terms of y and r. So grades-wise, getting to that last arrangement is going to get you an excellence. Consistently... yeah, it looks like there's a few things here. I would actually get you guys to check the answer schedule. I guess the first thing you get an achieved for is, I think if you do that, you get an achieved straight away. Yeah, multiply LHAs. So let me just show you guys the schedule, and it looks like there's like steps. So if you do the first step, you can get like an achieved, and where is the answer schedule? There you go. So doing that first step is going to get you number 1, which could get you an achieved. But for a merit, you kind of need like 2 steps. So 2 of steps. So either you're doing number 1, number 2, or number 3, one of those things to get a merit. And then final correct rearrangement is going to get you an excellence. Yeah, it's again, I've seen this type of question in level 2 algebra exam as a merit. And I guess it's a nice one because I mean, like if you do level 2 merit, you kind of would expect that same question to be level 1 in level 1 to be an excellence question. Cool, guys, that is question 1. We go to question 2 very shortly. All right, guys, so let's go to question 2a. So what do we have here? We've got, given the perimeter is 34, find the value of x. So all we're doing is adding up those 4 sides, putting it equal to 34, and solving it. Now it does say that you can't actually, you've got to form and solve a linear equation, so you can't just guess and check for this, guys, unfortunately. So we're going to go x plus 3. We're going to start from starting from where? Starting from this side, and I'm going clockwise. So x plus 3 plus x plus 2 plus x plus 2x minus 1, and all of this is equal to 34. So I collect my x's. So I've got 1, 2, 3, 4, 5. So that's 5 x's. Then numbers, 3 plus 2 is 5. 5 minus 1 is 4. So I've got 5x plus 4 equals to 34. Rearrange this. I've got 5x is equal to 34. Positive 4, so when I bring it to the right-hand side, it's minus 4. And I've got 5x is equal to 30. X is equal to 30 divided by 5, which is actually going to give me that x is equal to 6. So grades-wise, achieved for this question. And we move on. Yeah, fairly quick question. All right, so with the second question, what we have is solve the inequality. We've got a quadratic on the left-hand side, and we've got a quadratic on the right-hand side. And I guess the first thing you really can do is see if there's anything you can cancel out here. And I'm looking at both of those sides here, and I can't really see any common factors that I can get rid of. So you know what? Have to expand this. I've got to do the whole FOIL thing. Tops and bottoms. So let me do the first one. So I got 3x times 2x, which is 6x squared, minus 3x. Then I've got 2 times 2x, which is 4x, 2 times negative 1, which is negative 2, and all of that is less than or equal to 6x times x is 6x squared, 6x times minus 3 is negative 18x, 1 times x is 1x, 1 times negative 3 is negative 3. So at this point, I want to get rid of whatever I can. I guess the first thing I can get rid of is 6x squared and 6x squared because they're both on the left-hand side and the right-hand side. And on the right-hand side, 4x minus 3x is x. I've got x minus 2 is less than or equal to negative 18 plus x is negative 17x minus 3. I'm going to bring all the x's to one side and take the numbers to the other side. So I'm going to leave x minus 2. Negative 17x when it comes to the left-hand side will become positive 17x. And now this is less than or equal to negative 3. I'm going to get rid of the negative 2. But before that, x and 17x is 18x less than or equal to minus 3. Negative 2, when it goes to the other side, it will become positive 2. Remember, the only time I actually change the symbol of the direction of the symbol is when I divide by a negative number. I'm not dividing here, I'm just moving the positive 2, so nothing's going to happen to the symbol. So then I've got 18x is less than or equal to negative 1, and then x is less than or equal to negative 1 divided by 18. And because 18 is a positive number, I don't actually change the direction of the symbol. So grades-wise, correct inequality find, you're going to get a merit. Anything before that, you're going to get an achieved. So expanding either quadratic equation and simplifying it, you'd have to simplify it to get an achieved. So somewhere there. And then, yeah, so you can actually make like a whole lot of mistakes here. And if like anywhere you go after that expanding part, you could still get an achieved for it. All right, so let's go to question C. So with question C, what we've got here is we've got two rectangles. We've got perimeter that's been given to us. Perimeter of rectangle A is 46. Perimeter of rectangle B is 32. Looks like we've got a set of find the length and width of rectangle A and B. All right, nothing much apart from straightforward simultaneous equations. Because to find a perimeter, you remember we've got to add all the sides together. So we've actually got 7p there. We've got 3q there. You got 2q here and 5p there. So you could have actually done half of it. It doesn't really matter. So let's do this way. So I'm going to do rectangle A first, which is 14p plus 6q equals to 46. Now the reason I got 14p was because I got 7p and 7p, which equals to 14p. And I've got 3q plus 3q, which equals to 6q. And of course, the perimeter of that is 46. Now let's look at that second rectangle B. I got 10p plus 4q equals to 32. So there's my 2q's, which is the 4q there. 5p and 5p is equal to 10p. So once I've set up those two equations, now it's just a matter of, doing simultaneous equations. Let's see if I created enough space here. So I'm going to write this up here, my two equations. Oh no, we can just do it actually. So let's just drop a line here. So I've got 14p plus 6q equals 46. Then I've got 10p plus 4q equals to 32. So what can I do here? I could multiply. I want to get rid of the q, right? Because I mean, I don't want to be multiplying the bottom equation by 14 because that's just going to take forever. So what I'm going to do is I am going to multiply the top equation by 2 because 6q times 2 will give me like 12q there. And as for the bottom one, I'm going to multiply by 3, so that 4q times 3 is going to give me 12q, which means I can eliminate the q's and things will be a little bit easier. So let's do this. We're going to multiply this entire top equation by 2. So we've got 14 times 2, which is equal to 28p. 6 times 2 is 12q. And then we've got 46 times 2, which is equal to 92. Cool. Next, we're going to do the bottom one. So we've got the entire bottom equation multiplied by 3. So 10p times 3 is 30p. 4q and 3 is 12q. And then 32 times 3 is 96. Now, looking at this, I can kind of see, okay, this is kind of working out nicely, but I don't really like working with negative numbers, right? Because I always end up making like silly mistakes. So what I'm going to do is I'm going to rewrite this equation where I'm going to put that 30p on top, and I'm going to put the 28p at below it, equals 92. And what I'm going to do is I'm going to take away 30, so I'm going to subtract it. So I've got 30p minus 28p, 12q minus 12q, 96 minus 92, which means I am going to end up with 30p minus 28p is 2p, 12q and 12q disappears, 96 take away 92 is 4. So I've got 2p equals to 4, then I can say that p is equal to 2, because 4 divided by 2 is 2. I've got p, and now I need to work out what q is. And to do that, I can go to any one of those equations, right? So I'm going to go with that second equation, which is 10p plus 4q equals 32. And I've got 10 times 2 plus 4q equals to 32. I've got 20 plus 4q equals to 32. I need to rearrange, so get rid of that 20 to the other side. It becomes minus 20. And if I was to keep going, I've got 4q equals to 12, and q is equal to 12 divided by 4, which gives me q is equal to 3. Right, let me just move that for a second. Give me 1 second. Let me just rearrange a few things. Now here's the thing. If I go back to the question actually says find the length and width of rectangle A and B. I've got what P is. P is equal to 2 and Q is equal to 3. So I'm kind of going to do this up here so you guys can see this, right? So this is rectangle A, and this here is rectangle B. So now A, we've actually got 7P and 3Q. Now 7 times 2 is actually equal to 14. Q is 3, so 3 times 3 is 9. So we can actually say rectangle A is 14 by 9, and it's all in centimeters. And then rectangle B was 5P, which goes into 10, because 5 times 2 is 10. And then you've got 2Q, which is 2 times 3 is 6. So we can say rectangle B equals 10 centimeters by 6 centimeters. Units not required for this, guys, just the actual numbers that are important. And you got to give the dimensions of the two rectangles to get an excellence. So let's say you make a mistake somewhere, you can still get a merit as long as you consistently find the, using like the wrong numbers, you can still get the wrong dimensions. You can get a merit for that as well. Correctly combines the equations in one variable gets you a merit. So up to here could also get you a merit. Achieved forms both equations for perimeters, must have combined like terms. So that means you're looking at achieved somewhere here and here. And again, if you solve for one of those variables, you could potentially get an achieved as well. Cool. Big question for an excellence, but not as horrible as I've seen in previous years, to be honest. Cool. Let's go to the next one, guys. All right. Another one of these questions. I think I spent like pretty much an entire tutorial session on this. If you guys, I will put the links up at the end of this video. Go check out those live tutorials from like the last couple of years, and we do so many of these questions, and I guarantee it by like 1 hour you'll be pretty much set. It's kind of those questions where you just set and forget. You just know what you're doing. Anyway, let's have a crack at this. So our first thing we really got to do is we got to get a common denominator. So what we're going to do is we're going to break it up a little bit. We've got x plus 2, and I always do this, and people are like, why does he always give this much space? It's not like he doesn't have it. But I'll show you guys why I do this, right? One of the things I do this is because in the denominator, I've got 3 and 5. And I know that 15 is my lowest common multiple between them. So I've got to multiply the denominator by 5 and the numerator by 5 as well, and making sure I put a bracket around that x plus 2. And as for the second one, maybe I should have put that minus here. There we go. And as for the second fraction, I got to multiply by 3 and also the numerator by 3 as well. Because when I do this, now the denominator is actually equal to 15. So what I've got here is 5 brackets x plus 2 over 15 minus 3 brackets 2x minus 1 over 15 equals to 1. Now, because 15 is the common denominator, I can put all of this under the same denominator. And I guess this is the important part, because of that negative. That negative just gives so much grief to people, right? They always do that negative. I'll show you what I mean by, I'm talking about right here, this negative here, and this negative causes so much grief for people because they always forget this negative. Especially if you don't put the brackets, you'll definitely forget it. So that's one of the reasons why I tend to do it this way. All right, let's get rid of the denominator, move it to the other side. So we've got 5 bracket x plus 2 minus 3 bracket 2x minus 1 equals 1 multiplied by 15. Well, 1 times 15 is just 15, so we're going to put that. I guess I'll have to write it down. Now we're going to expand the brackets. So we've actually got 2 brackets to expand out. And when we do that, we're going to get 5x plus 10 minus 6x plus 3 equals 15. All right, simplifying it, we've got 5x take away negative 6, sorry, 5x minus 6x is equal to negative x plus 13 equals to 15. And then negative x is equal to 15. Positive 13 comes to the other side, will become minus 13. And we're going to get negative x is equal to positive 2. And then we can say x is equal to negative 2. Because just flip that symbol over to the other side. Or if you go 2 divided by negative 1, you're going to get negative 2 as well. Grades-wise, this question is worth a merit. For achieved correct arrangement for both numerator does not need to be expanded or simplified. Oh, wow, 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 really? So here, getting to that point can actually get you an achieved. And all we're really doing is cross-multiplying and just putting it with the same denominator. And of course, if you stuff up your answer and you still get like some sort of, you show the correct working, you could also get an achieved for that as well. Cool, let's go to question E. Okay, so with question E, what we've got is we've got a rug and then we've got some space, like a rectangular room, right? Now it says the area of the whole room is double the area of the rug. So let's actually work out the area of the rug, because that's nice and simple. Area of the rug is base times height, which is 3 times 2, which is going to be 6 meters squared. Now double that means the area of the room is going to be 12. So area of the room, we can say that it's going to be 12 meters squared, because it's double of 6. And now we need to come up with a equation for the base and the height of this rectangle. Now, if you look at the base of this rectangle, what we've got is from here to here is x, and from here to here is 3, and then from here to here is another x. So what we can kind of see here is our base is actually 2x plus 3. And we're going to do this similarly we've got from here to here is x, from here to that middle is 2, and then from there to there is x. So what we're going to have here is the height of this rectangle is going to be 2x plus 2. And guess what? That's your base and height. So base is 2x plus 3 and height is 2x plus 2. And our area is equal to 12. So let's write this as an equation. We've got 2x plus 3, base times height is going to give us the area, which is equal to 12. So all we're really doing here is expanding this equation, putting it equal to 0, solving it, and you're pretty much done. So let's expand this equation. We've got 2x times 2x and 2x times 2, which is going to give us 4x squared plus 4x. And then we've got 3 times 2x and 3 times 2, which is going to give us 6x plus 6. All of this is equal to 12. We're going to end up with 4x squared plus 10x plus 6 is equal to 12. Now it's a quadratic equation, so we want to make sure that one of the sides is going to be equaling to 0. So I'm going to get rid of the positive 12, bring it to the left-hand side, make it minus 12, and all of that is equal to 0. Okay, so once that's done, we're going to simplify it. We're going to get 4x squared plus 10x minus 6 is equal to 0. Now at this point, you can kind of see, okay, there's a 2 is a common factor, so we can actually take it out. We're going to get 2x squared plus 5x minus 3, and all of that is equal to 0. We can carry the 2 across to the opposite side. 0 divided by 2 is going to be 0. All right, so 0 divided by 2. Let me just do that properly, because I know sometimes you guys are like, I get a message later night going, it's like, what happened to the 0? Or what happened to the 2? So, well, 0 divided by 2 is 0. So now we're going to do that whole little, you could use a quadratic formula here, or you can just do that partition thing. So we're going to do the partition thing, which is we've got 2x squared plus 5x minus 3 equals to 0. So I've basically got 2 times minus 3, which is negative 6 and 5. So I'm looking for two numbers that multiply to negative 6 and add up to positive negative 6 plus 1, is it? No, sorry, let's try that again. It's going to be 6 times negative 1 and 6 plus negative 1. There we go. So I'm going to replace that 5x with 6 and negative 1. So when I rewrite this, I'm going to get 2x squared plus 6x minus 1x minus 3. So all I've done there is I've split that 5x as 6x minus x. So next thing, I kind of split them in the middle, take out the common factors. I've got 2x, x minus 3. And then on the right hand side, I've got negative 1, x, sorry, that should be x plus 3. And of course, remember, all of this is equal to 0. X plus 3 is a common factor, and my second factor is 2x minus 1, which all equals to 0. So just to reiterate, the 2x is from there to there, and the minus 1 comes from in front of the x plus 1, x plus 3 bracket. So now we've got to solve this. So we've got x plus 3 equals to 0, or we've got 2x minus 1 equals to 0. So in this case, I've got x equals to minus 3. And in the second case, I've got 2x is equal to negative 1. Switching over will become positive 1. And then x is equal to 1 divided by 2. So now we've actually got two answers here. We've got x is equal to negative 3 or 0.5. But the thing is, if you go back to that diagram, that rectangular room, you can't have x can't be negative, all right, because it is a measurement. It's a unit of length, so therefore x is equal to 0.5. And I think you can actually put down as 0.5 meters if you want to. Yeah, so, and for excellence, you actually have to mention the correct positive solution. with evidence that correct negative value disregarded. So you've got to actually mention that x can't be negative or ignored or whatever to get the full grade of excellence. As for merit, simplifying to quadratic equation number 1 equals 0 not required. Oh wow, so merit is here at that line. Just one of them is one of, or if you make a mistake in your quadratic equation, somewhere you make a mistake and you recognize. So if you make a mistake and you still get an answer, you could still potentially get a merit for it. Achieved is correct forms, correct expressions for both lengths in terms of x. Wow. So that's still going to be this here, which is weird because simplification forms correct in terms of x. Now I would imagine it's this line here, because that's correct expression for lengths of both walls in terms of x. Yeah, so funny looking schedule again. So forms correct expression for both walls, equation to equated to 0, correct consistently simplifying. So if you make a mistake here and you still equal to get it equal to 0, you could get an achieved. And then you make like a mistake with the factorizing, you can get an achieved. So as you guys can see, lots of mistakes that you can make and you still can walk away with an achieved. But again, seen a question like this at level 2, but a little bit more challenging than this one. So I think it's a fairly fair question in this circumstances. But yeah, guys, that's basically question 2, and we'll take a short little break and go to question 3. Okay, so question 3a, we've got what is the area of the square with sides 3x plus 5? So, okay, so it's a square. And the side is 3x plus 5. 3x plus 5 because it is a square. And all we got to do is just expand it out, guys. So we got 3x plus 5 times 3x plus 5. So FOIL, first, outs, ins, whatever. Basically, we're just expanding the brackets. We're going to get 9x squared plus 15x plus 15x plus 25. And you've got to simplify the quadratic, guys. Otherwise, they don't give you an achieved. So make sure you do that final step of like putting all the x's together, the x squareds together, because otherwise this will not get you an achieved if you don't actually do that simplification. Cool, that's question 3a. Let's go to 3b. Okay, so question 3b. Again, tons of questions like this in the tutorials if you want to check them out. Again, it should pop up at the end of this video, or just have a look at the live tutorials that I've done in the past kind of couple of years. We do lots of questions like this. So let's have a crack at this. And I guess that if you guys have been watching my tutorials, you kind of will pick up straight away that 16 can be written as 2 to the power of 4. And that is pretty much what we're going to do here as one of our first steps. So we've got 2x multiplied by 2 to the power of 3x minus 8 equals 2 to the power of 4. Now, the second part is I'm going to combine the bases on the left-hand side. And when you're multiplying with the same base, the powers get added. So we're going to get 2x plus 3x minus 8 equals 2 to the power of 4. Simplifying this, we're going to get 4x minus 8 equals 2 to the power of 4. And because both of these bases are the same, we can actually say, because the bases are the same, the powers must equal each other. So we can rewrite this as 4x minus 8 equals to 4. And 4x is equal to 4 minus 8. When it comes to the other side, will become plus 8. And we've got 4x is equal to 12. And then x is equal to 12 divided by 4, which actually gives us x is equal to 3. So grades wise, we are looking at x equals to 3 for a merit. Consistently forming a linear equation from a base of 2 is achieved. So you could get achieved here. Simplification of the powers of 2 on the left-hand side. Left-hand side, that's here. Also, you could get and achieved. Cool. Let's go to the next question. Oh man, that is one long question. But you know what? We'll get it done. So, unfortunately, this one, we actually have to kind of give it a bit of space. So I'm going to go 2x minus 3. I'm going to put down minus 2x plus 1 equals to 3x plus 5. Now I'm going to work on the left-hand side first, right? Left-hand side, I've got two different denominators. I've got x minus 3 and I've got x plus 1. So if I want to have the same denominator, I've actually got to multiply both of them. All right. So in other words, I've got to multiply by x minus 3 in the denominator and the numerator. And as for the other side, I've got to multiply x plus 1 in the denominator and also in the numerator. So this gets rewritten as 2x plus 1. I've got x minus 3 and x plus 1. So that's what that green highlighted part was. Minus 2 over x plus 1 multiplied by x minus 3 in the denominator. All of this is equal to 3x plus 5. Now you guys got to be patient with this one because this is going to take a little bit of time, but we're going to try and minimize the space as much as we can. So now that we've got the denominators as the same, I'm going to put all the numerators in one line. So I've got 2 bracket x plus 1 minus 2 bracket x minus 3. All of that is over x minus 3 and x plus 1 equals 3 over x plus 5. So I've got to expand all the brackets out, right? So in the top numerator, I've got 2 times x and 2 times 1, which is going to be 2x plus 2. Then I've got negative 2 times x and negative 2 times 3, which is going to give me negative 2x plus 6. And in the denominator, I've got x minus 3 and x plus 1. I'm going to expand it, which is x squared minus 2x minus 3. And all of this is equal to 3 over x plus 5. So the numerator could be simplified now as just 8, because 2x take away 2x is going to disappear. And I've got 8 over x squared minus 2x minus 3 equals 3 over x plus 5. So at this point, what I could do is I could actually cross multiply. And I'm going to end up with 8 bracket x plus 5 equals 3 bracket x squared minus 2x minus 3. Another lot of expanding, but I'm going to write this equation here first so that we don't have to kind of dodge it from the bottom back to the top. So I've got to expand the next lot of brackets. So I've got 8 times x is 8x, 8 times 5 is 40, equals, expand the next lot of brackets. I've got 3 times all of those 3 things there, which is going to be 3x squared minus 6x minus 9. And of course, I've got to rearrange this so that it's a nice quadratic equation. So 0, I've got 3x squared minus 6x. 8x, when it comes to the right-hand side, will become minus 8x. Minus 9, and I've got 40, which becomes minus 49. It's a bit annoying that you guys get this kind of numbers, eh? This is just sad. But so anyway, 0 is equal to 3x squared minus 14x minus 49. Wow, that is an awful equation to be looking at if you're going to do the whole splits way that I used to show you guys before. But It such sucks that you guys have such a horrible number. But anyway, look, we're gonna have to carry on with this because we got to try and figure out what that final value is. Um, so what I've got here is I've got 49 times 3. Cannot believe that you need to do that. So negative 49 times 3, which equals to 98. Wow, come on, man. Negative 147. How are you guys supposed to actually do this in the middle of an exam? Try and figure out two numbers that multiply to 147 and add to negative 14. Really? That's just horrible. I'm sorry to say this, guys. I feel for you when you. I can't believe those of you guys that had to sit through this exam, you would have had this number to deal with. Seriously, that's just ridiculous. Yeah, just a bit frustrated again. It's all right. Let's kind of think through this through. Like 147, right? I mean, like, I'm trying to think for you guys. It's just, I'll just feel bad for you guys. But like, look, the number that we're looking for is 21 and 7. And it took me a while because I had to pause the video and kind of go, what the hell is this, right? So what we've got here is negative 21 times 7, which, you can't really be expected to remember that 21 times table, but because then I can go negative 21 plus 7 is equal to negative 14. I mean, once you get this part, it becomes easy, right? But still, it's just a bit mean to be doing this. So we've got 3x squared minus 21x plus 7x minus 49. Anywho, so what do we got next? We've actually got split them up into parts. So we're going to rewrite this as 0 is equal to 3x and x minus 7. And then here we've got plus 7, x minus 7. So our two factors are going to be x minus 7 and 3x plus 7. Just to reiterate, the 3x is from there, positive 7 is from there, and all of this is equal to 0. So our two values are, we've got x minus 7 is equal to 0, which means x is equal to positive 7. Or we've actually got 3x plus 7 is equal to 0. 3x is equal to negative 7. And then x is equal to negative 7 over 3. So those are our two values for this equation. The final two values is going to get you an excellence. I'm going to say, let's just have a look at the schedule, guys, for, there we go. So correct arrangement of numerator and denominator on left-hand side except unsimplified equations. So that could get you an achieved. So that means I'm talking about correct arrangement. So it's an arrangement, potentially somewhere here, either here or here, you could get an achieved. Factorizing of quadratic equation, that's if you make a mistake with the quadratic equation, you can still get an achieved. Rearrange equation to remove denominators, that's up to here, which also gets you an achieved there. And if you combines it into a single fraction, numerator must be simplified, could be a merit. Correctly combines into a single fraction. Yeah, it's a bit weird because I'm trying to figure out where that line is, because I would say that correctly combines into a single fraction. Numerator must be simplified. Surely this can't be merit. I'm going to put a question mark there. I'm not actually sure, guys. Well, that's MCAT for you. Just weird questions every now and then no weird questions, more like weird answer schedule. It's like, anyway, let's move on to the next question. Oh, wonderful. We've got another quadratic with a 2 in front of it. So I guess we got to do that first. Let's factorize 2x squared minus 3x minus 14 first. So 2x squared minus 3x minus 14. we are going to get, what are we going to get? Negative 14 times 2, which happens to be negative 28. And we're looking for two numbers that multiply to negative 28 and add to 3. So it's 7 and 4, nice and simple. So we've got negative 7 times 4, negative 7 plus 4. And so we can rewrite this as 2x squared minus 7x plus 4x minus 14. And of course, I'm going to split them into parts. I've got x, 2x minus 7 plus 2, 2x minus 7. And I've got 2x minus 7 and x plus 2 as my two factors. So x is from there, positive 2 from there. Okay, so let's go back to this fraction. Actually, no, I've got to do the 2x squared minus 8 first. So let's do that one. So we've got 2x squared minus 8. I'm going to take out the 2 as a common factor. I've got x squared minus 4. Then I can rearrange this as x plus 2 and x minus 2 because it's the difference of two squares. So now we can actually put the two things together. So in our numerator, we've got 2x minus 7 and x plus 2. In the denominator, we've got 2x plus 2, x minus 2. I can cancel out x plus 2 and x plus 2, which means my final answer is 2x minus 7 divided by 2 bracket x minus 2. So grades wise, we are looking at a merit for this. And anything that you do, numerator or denominator, fully factorized is achieved. So achieved could be either this or this. And then, of course, making like a consistent simplification. So if, let's say, you make a mistake with the factorization, but you still get the whole canceling thing correct, you could get an achieved for that as well. All right, so last question. All right, guys, so last question for this paper here. So what we've got here is total length of the painted lines is 20 meters. So the painted lines are in the diagram below. So we're going to assume that these are all the painted lines. So that's all my x values. And then this is my y values, which is 1y and 2y. So there's my first equation, right? I've got 3x plus 2y equals 20. Now the shaded region is 14 meters squared, so that's base. So it's rectangle of base of x and y. So x and y doesn't matter. So we can say x times y is equal to 14. And we got to figure out what the possible value of x is. So we've got two equations here. We got 3x plus 2y is 20, and xy is 14. So a couple of different ways of doing this. I mean, you could rearrange and then substitute. What I might do is like in day 2, I'll do the different version of this, but let's just, I haven't actually seen day 2 yet, but let's have a crack anyway in this. So what we're going to do is we're going to rearrange this. We're going to rearrange this as, we're going to put x, get rid of x on the other side, right? So we've got 2y equals 20, take away 3x, and then get rid of the 2, we're going to get y is equal to 20, take away 3x divided by 2. And the reason I did this is because I wanted to have y by itself so that I can replace the y in xy equals to 14. And that's what I'm going to do. I'm going to do x multiplied by 20, take away 3x divided by 2 equals to 14. I'm going to get rid of the 2. So when I get rid of the 2 to the other side, it will become multiplication. I've got 14 times 2. I'm also going to expand these two, expand the brackets. So I've actually got 20x, take away 3x squared equals to 28, because 14 times 2 is 28. Rearrange, because I've got a quadratic here. 0 is equal to negative 3x squared. When it comes to the other side, it becomes positive 3x squared. negative 20x, sorry, 20x, when it comes to the other side, will become negative 20x. And of course, we still have the 28 as is. And yet again, we've got a horrible quadratic. Yay! Not. Surely they could give you guys some more nicer numbers, but clearly someone is not feeling generous with their numbers today. Anyway, let's do 28 times 3. That's going to be, what is it? 72. 24 is 72. Is it 84? Yeah, it's 84. So we are looking for two numbers that multiply to positive 84 and also add up to minus 20. Now, in the odd occasion, you guys would like, I know the last one, when we tried to do this, I kind of paused the video and did it in my head and came out. But what happens with you guys, right? Like, what would you do when you got 82 numbers multiplying to 84 and add to 20? The simplest way to do this is break it down one step at a time. So what do I mean by that? Let's go like this. All right, so we've got 84, right? 84 could be written as 2 times 42. 42 could be written as 7 times 6. Is that right? Yeah, I think so. Please be right. 6 could be written as 3 and 3 times 2. All right, so what we're really looking at is like the prime number tree that you guys would have seen, which is like 2 times 2 times 3 times 7. Is that right? 12 times 7, that looks right, 87. I don't want to re-edit this video, but let's hope this is correct so far. Okay, so now we are looking for a combination that is going to be minus 20, and it's also positive 84. What's going to be minus 20? Basically looking for a combination that's going to make a 20. So let's see, 14. Oh yeah, 14 and 6. There we go. So we can actually do 2 times 7 times 3 and 2. So 14 times 6. So what we're going to do is we're going to replace this with negative 14 and negative 6. Because then negative 14 times negative 6 is negative 84. Negative 14 plus negative 6 is negative 20. The numbers do work out. It's just a matter of like having a bit of time to play around with this. So we got 3x squared. I am going to put in minus 6x minus 14x plus 28. No, the 28 is, I'm going to put that in blue so you guys can see where that negative 20x dissipated into. Okay, so we're going to split this up into parts, factorize the first two elements. So we've got 0 is equal to 3x, x minus 2, and then we've got minus 14, x minus 2. So 0 is equal to x minus 2 and 3x minus 14. So there's the 3x, there's the 14. We are good so far. Now let's just try and figure out what those two answers are. So we've got x minus 2 is equal to 0. So we can say that x is equal to positive 2. So there's our first solution. Our second solution is 3x minus 14 is equal to 0. So 3x is equal to negative 14. When it comes to the other side, it becomes positive 14. And we can leave x by itself, which is 14 over 3. So our two answers are x is equal to 2 and 14 over 3. So those are two answers for x and y. And you might be wondering, how's that possible, right? Well, it's just, that's the funny thing about rectangles, right? Remember, rectangles have this whole property where like, if something has like 10 by 1, all right, the area is 10 by 1. But for the rectangle that's actually 1 by 10 also has the same area. So that's why you kind of get like that two answers for x in this case. All right, so you could have one answer that looks like this, or the second answer where it actually looks like kind of something like this, where the y is really long, it's longer than x. So where that'll become x, x, and x, and then that's y and y. So that's why you got those two different answers. So both of those two answers you need for an excellence. Forms an equation in one variable gets you a merit. Forms an equation in one variable gets you a merit. Really? And again, see, like I'm wondering whether if you can actually put, you'd be getting a merit right there because that's equation in one variable. Achieved forms the equation 3x plus 2y equals to 20 as an achieved. So that one right there at the top is going to get you an achieved. Again, I'll show you guys the answer schedule. So consistently factorize this quadratic equation. Let's say you make a mistake in the quadratic equation and then you come up with like a couple of those answers at the bottom. They're the wrong answers, but you've got the right, like maybe a slight little error somewhere. You could still get an achieved for it. Consistently forms an equation in one variable. Look, so if you make a mistake with the equations, but you're still trying to show that you're trying to make the equation with like one variable, so that's like having no y, but rather having all the x's. Or it could be the other way. You could have no x's and have all y's as well. Whatever. So that could also work as well. Yeah, so that's pretty much it in terms of grade. Overall, this paper, apart from that, which one was it? Like a couple of questions ago, we saw that this thing right there, the 147. That was a bit annoying, but apart from that, I thought the paper wasn't actually too bad. Quite a nice paper actually, and I didn't spend too much time on it except the last question because I was kind of stuck on that stupid numbers for a while. Yeah, just some word of advice for you guys if you guys are doing the MCAT this year, and if you are actually, because I'm not sure what's happening with some of the schools. I think some of the schools are not doing it, but not really sure. Stay tuned on the channel, guys. When and if I do tutorials, you will kind of get notifications. Just follow us on Instagram because usually when I do tutorials, I put up notifications there. Yeah, my tip for you guys, if you're doing this assessment in September, it's a few months away. There is a ton of material, revision material available on my channel. Please, please, please pass it on to other people because a lot of kids don't find out about this channel until like 2 days before the MCAT and they're like starting to freak out. Yeah, attempt all the questions. Hey, don't leave any questions empty. Sometimes even writing like an equation could like score you an achieved. And so what do I mean by that? Like if you go back, just want to go right to the end just to show you guys what you might need for, let's see, achieved merit excellence. There we go. For an achieved grade, you only need like 3 achieved questions correct, but you got to get them in like multiple, like at least in 2 different questions. For merit, you need to get like 3 merit questions correct, 1 merit in each question, or 1 merit in one question and 2 merits in another. Excellence. You need to get 3 excellence grades. So that's that whole T thing that they do. Don't worry about it. You just need to get those 3 excellence questions correct to get an excellence. Yeah, when you get to level 1 tables equations, that's a completely different ball game as well. Cool, guys. That's pretty much it for this. Yeah, good luck for your exams. Any feedback, drop it in the comment section. Any questions, drop it in the comment section, or just send them to the Instagram or Facebook handles, or even my email. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.